All right, let's look at natural domains. All right, there are a couple of things that you look for. Whenever you have a fraction, you have to make sure that the denominator is non-zero. Right. Or if you have a square root, a fourth root, any eventh root, you have to make sure that inside the square root or eventh root has to be non-negative. All right. So let's look at a couple of examples. First one is a rational function f of x equals x plus 1 over x minus 2. All right, you can see that there's a fraction there, so we have to make sure that the denominator here, so this guy cannot be 0, so non-zero. Right, so we have to solve this inequality, so x minus 2 is not equal to 0. Then what you need to do is you try to isolate x, add 2 to both sides, just like the equality, so you have x cannot be equal to 2. Right? So the natural domain is going to be all real numbers except for 2, right? Because x cannot be equal to 2. Or in an interval notation, so domain is going to be, right? So we have to eliminate 2, but everything else should be included. So you have a negative infinity all the way to 2, then skip 2, then go all the way to positive infinity. Right? So this is interval notation for the same thing. Oops. Maybe I should use a different color here. So this is the answer. Alright, so let's look at the second example. G of x is equal to 1 over square root of 5 plus x. Right? There are actually a couple things going. There's a fraction, so we have to make sure that the denominator is non-zero. Then there's a square root, so we have to make sure that inside the square root must be non-negative. Right? So following the number one rule, right? Rule number one, we have to make sure that the denominator, so this guy right here, is again not equal to 0. Right? So we have this inequality again. So we have a square root of 5 plus x is not equal to 0. Then let's try to isolate this guy, x. So square both sides. So you have a 5 plus x cannot be equal to 0 squared is still 0. Alright, then we're gonna subtract 5 to isolate x. So x is not equal to negative 5. Right? So rule number one tells you that x cannot be negative 5. Right? So let's look at the rule number 2. So rule number 2 said that inside the square root, so in this case, this guy has to be non-negative, which means that it has to be greater than or equal to 0. So we have this inequality, 5 plus x has to be is greater than or equal to 0. Alright, then we're going to isolate x again, so subtract 5. So you have x has to be greater than or equal to negative 5. Alright, so we have to have a couple of conditions we have to satisfy at the same time. So x is not equal to negative 5, and x is greater than equal to negative 5. So which means that you need to combine that. So x has to be strictly greater than negative 5. So therefore, the domain is, right, so you have negative 5, so you have negative 5 And since x cannot be equal to -5, we have to use a parenthesis. So that's exclusive, not including -5. But everything above that should be included. Right? So that's the domain for the second function. Right? So a domain can be determined by whoever creates the function, but this is called a natural domain. These domains are determined by the formulas themselves. Right? Then you just need to look for a couple things. Make sure that the denominator is non-zero. Make sure that the expression inside the square root or any eventh root has to be non-negative. And use those two things to find the condition. Then you should be able to find natural domains. All right, that's it. I hope that this was clear.